Hello friends, good morning. Welcome to our chemistry class. Today we are going to discuss about a topic in inorganic spectroscopy. Okay friends, let us start. First, proton NMR of metal hydride. See, metal hydride metal means to the metal here the hydrogen is attached. See, here we should know one point, that is here hydrogen is more electronegative. We know that whenever a particular atom is electronegative, it attracts the electrons from the adjacent atom. So that as here the hydrogen is more electronegative, it takes electrons from the metal. See, from the metal means we know in the metal d orbitals are present. That means the electrons present in the d orbitals or moves towards the hydrogen. Yeah, this thing we should know. Okay, see, metal hydrogen. Observe here, as I already said that when compared to metal, hydrogen is more electronegative, so that the electrons moves towards the hydrogen, so that here the hydrogen becomes shielded. See, whenever the electrons moves to the hydrogen, here the hydrogen gets negative charge. We know that. Yeah, see, as the electrons are moving towards the hydrogen, it will get negative charge and it becomes highly shielded. I hope you understood. See, next. Due to paramagnetic shielding of hydride by d electrons of metal. See, here what's happening? This hydride is getting shielded. Okay, how it is shielded means here the shielding is paramagnetic. This point is very important. Okay, this is paramagnetic. See, already I said that here the shielding is happening, no? So this shielding is paramagnetic shielding. And how this is happening means the electrons present in the metal are moving towards the hydrogen. Yeah, next. See, this is the thing which we have to remember, and it is most important. Okay, see, shielding is directly proportional to electron density on hydrogen. See, means if electron density on the hydrogen increases, shielding also increases. Means if the movement of electrons towards the hydrogen increases, then what will happen here? Electron density on the hydrogen increases, so that shielding also increases. Okay, next. See, these 2 points are very important. Okay, yeah, let's focus. See, we know in metal from d1 to d9 means whenever we fill electrons in the d orbitals from d1 to d9, any d orb means we can take electrons from d1 to d9. We may take anything. Okay, that is paramagnetic. Okay, in metals from d1 to d9, that is paramagnetic. We know paramagnetic means unpaired electrons are present. Okay, yeah, this thing we have to remember. Next, see, in this metal hydrides d1 to d9 only. d1 to d9 means unpaired electrons are present. So for these the chemical shift value ranges from -3 to -25 parts per million. Okay, this is the unit. Okay, so we should remember that metals having the orbitals from d1 to d9, the chemical shift value is -3 to -25. Okay, next friends, this is very important. This thing we have to absorb, because if we understand this, it is very easy for us to solve most of the problems. Okay, yeah, just focus on this. We know actually these are the values like chemical shift values like that. Okay, and this is the 0. We know for tetramethylsilane its value is 0. We know that. See, this is the right. See, just focus on this. This is right side and this is left side. Okay, here the right side means here it is the upfield. Okay, right side means upfield, and means these values are away from, means whenever a particular atom or anything is away from electronegative atom, means whenever it is away from electronegative atom, that means here it is upfield. Okay, upfield. This is right side. Okay, right side. Next, see, means here this is towards the left side, means towards the electronegative atom. Just assume that here, means just for your understanding I am telling this, okay. Assume that here electronegative atom is present. See, here the scale is moving towards the electronegative atom, means towards the electronegative atom means downfield, okay. Here it is away from the electronegative atom, that is upfield. We can also say this as downfield means de-shielding, okay. Downfield means de-shielding, upfield means shielding, okay. Next, see, for metal hydrides, chemical shift value ranges from -3 to -60 parts per million, okay. This thing we have to remember. Yeah, next, see friends, from all the above points we have, means we have to remember this, and this is very easy to remember. Yeah, let's see. See, if the number of metals increases, shielding of hydride increases. Means shielding of hydride increases means what? Electron density on hydrogen increases. See, if the number of metals are more means they donate electrons to hydrogen. That means electron density on the hydrogen increases. Electron density increases means shielding of hydride increases, means here all are directly proportional, okay. Next, we know Cp means we usually use this in 18 electron rule, heptacity, means we have already used this. See, here one thing we have to remember, Cp means this one, we know cyclopenta, this one, okay. Cp star means in place of hydrogens we have to substitute methyl groups. This is very important, okay. See, Cp means we know just this one, means here we know already here 2 hydrogens are present. No, only one hydrogen is present, because here one double bond is present, no. Yeah, so here the hydrogen is present. Whenever we substitute methyl groups in place of hydrogen, we will get this Cp star, okay. Next, finally I want to conclude saying this is important, okay. Yeah, from D1 to D9 the chemical shift value is negative. Yeah, this is important friends, okay. The chemical shift value is negative and it may ranges from -3 to -25 parts per million, okay. Yeah, whenever we will take, means whenever we take D0, it have the chemical shift value like +7.2, okay, +7.2 parts per million, okay. Means example for the compound having +7.2 parts per million is this one. See, here we have used Cp2, means see, that's why only I told this. Cp star means here in place of hydrogen methyl groups have substituted, okay. So this is Cp2 star and this is zirconium H2, okay. Yeah, here the oxidation state of this Cp2 star is -1. Yeah, zirconium's oxidation state is +2. H2 means here -1, okay. Yeah, this one means just this is an example for D0 complex having chemical shift value of +7.2 parts per million. Next, D10. D10 means it will have chemical shift value of about +3.5 parts per million. Here we have to remember one thing friends, just D0 and D10 means it will have positive chemical shift values, okay. D0 and D10 means positive chemical shift values. D1 to D9 means negative chemical shift values. See, this is a complex and this is an example for D0 having positive chemical shift value. See, HCu +1 means here just I mentioned the oxidation state of this copper, okay. This is a tollyl group and here we have taken 3 times. Yeah, I hope you understood friends. Okay, thank you.